Hello, and welcome to this edition of e-learning. We're going to talk about a logarithm. So 7.3 is the introduction to logarithms. What the heck is a logarithm? I'm glad you asked. A logarithm, it's the inverse function of an exponential function. Just like division is the inverse or opposite of multiplication, a log is the inverse or the opposite of an exponential function. So first, the parts of a log. Here's how you write it. The log, short for logarithm, the log with a base of b here. Every log has a specific base, just like every exponential, b to the x power equals some number a. Just like every exponential has a specific base, every logarithm has a specific base as well. This value is the input to the log. Here we've noted it as a. And what that log equals is the output. So here's a couple of examples. Log base 2, and here's how you say it. Log base 2 of 4 equals 2. So this log base 2 of 4, it has a value of 2. This log base 5 of 125 has a value of 3. And I'll show you why once we talk about the meaning. But I want you to first notice that these logs, they have different bases. The base is important. The input on this log is 4. The output is 2. The input on this log is 125. The output is 3. So what's the meaning of a log? A log is asking, what do I need to raise my base to? What power do I need to raise my base to for it to equal 4? And I suggest you get used to doing these like circular arrows to really understand how you can go from a log form to an exponential form. But this log means take base 2. If I raise it to the second power, 2 squared equals 4. And that's true, isn't it? That's the meaning of a log. Take a look at this log. It's the same one that we talked about before. This is saying, what number do I need to raise 5 to for it to equal 125? 5 cubed equals 125. And so that's what the meaning of a log is. It's just asking, hey man, what exponent do I need to raise my base to get my input? And so the output of a log is related to the exponent. It's related to the exponent on an exponential. Do you see it? The input of the log is related to the output of the exponential. And the base is the same on both log and exponential. So, you're going to have to convert from log form to exponential form and go the other way with it. Convert from exponential form to log form. Let's start with converting a log into an exponential form. So if we're given this log, first of all, what's the base? It's 6, right? Input is 216, the output is 3. By the definition of a log, this is saying that 6 to the third power equals 216. And so for me to write this in exponential form, I just need to use the same base on the log, 6, as a base on my exponential. And now this is going to be my exponent, 6 cubed equals 216. So this is the log form. This is the exponential form. Just like this problem here. The log has a base 4, so for an exponential form, I could use the same base. And the log is saying that 4 raised to the second power equals 1/16. And so we can convert it by saying 4 squared equals 1/16. This is log form, this is exponential form. To go the other way, to convert from exponential form to log form, well, I would start by realizing that 14 is the base on the exponential here, which means that the base on the log will also be 14. So I would just start by writing log 14. Keep in mind that the exponent is the output on the log. If you can remember those two things, then what's left to do with the output on the exponential is to use it as the input on the log. Practice makes perfect. You're just going to have to practice these. It might be confusing, but start with the same base, log base 14. The exponent's 2, so that log equals 2. And the input is whatever this equals, 196. Just like this one, base is 36, raised to the 1/2 power equals 6. Well, I can convert it to log form by using the same base, log base 36 of 6 here. 6 is what it equals, of 6 equals the exponent, 1/2. Let's go back to the parts. Base here, these numbers should be written as like a subscript. It's written below the log. Okay, so like that's why I wrote this 2 low here. That's why I wrote the 5 low here. Okay, all the bases should be written as a subscript. So this is how you convert from exponential form to log form, and how you convert from log form to exponential form. All right, so next we want to talk about evaluating the logs. Evaluating is just the word that you will see on your homework and possibly on a quiz or test. That's just a word that means what's the value of the log? Like what does it equal? And so take a look at this log. First of all, it has base 12. Log base 12 of 144, what does it equal? Well, for us to evaluate that, we can use the definition of a log. Definition of a log means that this base 12 raised to a certain power, now we don't know what this is yet, right? Let's call it x, equals 144. So you can go to your calculator and just start raising 12 to certain powers, or if you remember how we solved these by finding the same base, it's the same thing. 144 is 12 squared, which means that x equals 2. And so you could just go to your calculator, and once you find that 12 squared equals 44, you found the value of this log, because 12 to that power equals 144, which means that this log equals 2. That's the answer. Why? Because that is what you raise 12 to get 144. Same thing here. The question is, well, what do we have to raise 3 to get 243? Let's see, 3 to get 243. 3 to the x equals 243, okay? Well, I'm gonna have to go to my calculator here because I don't know off the top of my head. I know that 3 cubed is 27, so maybe it's 3 to the 4th. Let's see. 3, where's my caret key? 3 to the 4th power equals 81. Oh, no, that's not it. What about 3 to the 5th power? Caret key, 3 to the 5th, yep, equals 243. So the value of this log, because 3 to the 5th equals 243, the value of that log is 5. So that's how you evaluate logs. Next, there's something called the common logarithm. Common logarithm is just a log that has base 10. Base 10 gets used a lot, and for that reason, most calculators, if not all of them, will have a log button. Notice, mine is, I hope you could see this, mine is right there. It says log. Do you see it? Well, they can't put every single base in the calculator, right? Because there's so many numbers that you could put for the base. But the common log with base 10, the way we write it is just log of something. We drop the 10 because if you don't see a base, you should assume that it's the common log, which means the base is 10. This button is in your calculator. So if it's a common log, for example, log of 100, since there's no base there, that means it's the common log. That means it's base 10, which means you could use your calculator to figure out what that value is. And so keep in mind, though, this is how you write it, log with no base. It is the common log. That's what it's called, common log. And its base is 10. So without the calculator, here's how we do it, right? We ask ourselves 10 to what power equals 100? Well, 10 squared equals 100, right? So 10 squared, the value of this is 2. If you wanted to use your calculator, though, you would just find your log button. Oops, sorry. So mine is under second, log, there we go, log of, what am I trying to evaluate? Log of 100, I believe. All right, log of 100, enter, and you'll see it equals 2. Your calculator only has the common log. And so you could do it both ways. You could do it this way if it's an easy power to raise 10 to, or, you could use your calculator. So that's what the common log is. It's base 10. Now, because we love using our calculator, and because the common log is the one we can use, it would be nice if we had some way to change the base. Like this here, this example, this has base 16. It'd be nice if we could change the base somehow so that we could change it from base 16 to base 10. And we could put it in our calculator, right? And so we have this formula called the change of base formula. So for any log with base B and an input A, you could change the base to whatever base you want. Forget about changing it to anything other than the common log, because we want to change it to the common log so we can use our calculator. So here's how you change it. You just take the input here, and it goes in the input of a common log on the top of a fraction. Here's how I remember it. The A is higher, the input's higher than the base, so it's the one that goes on top. And we then use the base and put that in the common log. And then log of this base, or log of this input divided by log of the base here equals the same thing as log base B of A. I know it's kind of confusing, but let me show you an example, okay? So log base 16 of 64. I can't think of raising, let's see, 16 squared. What's 16 squared? That's definitely not 64. And so this is some weird number, right? And I can't really evaluate it without really taking a long time to do so. But I could change the base here. So I can go with the common base, that's why I didn't put a base there. Log of 64, since this was higher than 16, log of 64 divided by log of 16. And I could type this into my calculator to find what the value of this log is. And I'm gonna go ahead and do that. Let's see, log of 64 divided by log, let's see, log of, what is this, 16? Okay, looks like it equals 1.5. So actually I didn't have to round. A lot of times you'll have to round these. If that's the case, you can round to the, round to 4 decimal places if you have to round, okay? So the answer to this, 1.5. I used the change of base formula. And here it is in my calculator. I went ahead and typed in the log of 64 divided by log of 16, and my calculator gave me the answer. What about this log here? Okay, you might automatically know what this is, but if not, let's use the change of base formula to make it easy. So the input is 1 over 36. So I'm going to put that on the top of my fraction as an input into the common log. And I'll use the base on the bottom of my fraction as an input into the common log. And I'm going to type this into my calculator. Let's see. Log of 1 divided by 36, all of that, divided by log 6. Cool. Oh, okay. This one I didn't have to round either. This one equals -2. What does that mean? That means that 6 raised to the -2 power equals 1 over 36. That's how you use the change of base formula. All right, your homework's going to be posted in the assignment. If you have any questions, please post your questions to the discussion. WASP. Okay, talk to you later. Bye.